So, class, Joseph, what's up? What's up? What's up? Oh, all right. So, fundamental theory of calculus. I've mentioned this a couple times up until this point. Hopefully, I'll be able to explain it since we have been doing it already a little bit. When we get into example 2, that's for tomorrow's. You'll see what we've already done because we're like, oh, hey, that's just that. Okay. So let's see. So, fundamental theory of calculus, part 1. Let the function that is continuous on a closed interval from a to b. The function I is defined by this. I of x is going to be the integral from a to x of f of t dt. Now, if you notice, the variables don't match, do they? That's important to understand. So when we're doing this right here, the variables normally do not match. I can't say never, but they don't. I don't think I've ever seen it where they do match, just to mess with you, but no. Anyway, I could almost hear what you said. Why don't the variables match? And that's part of what we're doing, to show you from where to where. Okay, has properties that continuous on a to b. It's differentiable from a to b. Over for this, so I take I prime, which is going to be the derivative of I, is equal to the derivative of the function, which should just give me the function in terms of x. Remember how I said that the derivative, and then we had antiderivative, right? Because antiderivative is integration. So we're integrating a derivative. What is the opposite of square rooting? Squaring. And so what happens when you square a square root? It undoes the function, right? And you're left with just what's in the inside. That's the concept that we're getting here. So we're undoing the integration by doing the derivative. So here is the examples of this. Okay, for the sake of, because we don't actually have the nerdage yet to do these ones. So if I have the derivative of the integration from 0 to x, what's the derivative of 0? Isn't that just it's 0, right? 0 is a constant. It is a number. It is a constant, right? So right there in that, it's going to be whatever constant that is. So that's going to go away. So this one turns into, when I do the antiderivative of the derivative, I end up just having the square root. So I'm just changing the variables here. I'm just changing the variables. I'm plugging the variables in. And then top minus bottom. And the bottom is going to be a constant there. Same thing goes for this one here. I have the derivative of an integral, and it's top minus bottom. My bottom is a constant, and the derivative of any constant is going to be 0, isn't it? So that part's going to go away. Whenever I do this, it's going to be the top minus the bottom, and we're going to do more of that in a little bit. But it's just going to be the top, which is going to go into the place for my s right there. And when I take the derivative and the antiderivative together, it undoes the function where I just have this by itself. You notice I'm just plugging in the x's. Now, let's try to make it a little bit more complicated.
How come it gets the function but not the derivative? You know, 'cause, like, I don't know, my idea was
It's
like,
giving me the original function based on what it has here.
so deriving the antiderivative and the whole entire
Yes.
derivative thing.
Yeah, so like I said, I'm squaring a square root. That undoes it, so I'm left with what's inside there. And in this case, I'm taking the derivative of the antiderivative, so it's going to undo itself, and I'm left with just there. Now, let's make it a little bit more complicated. This one, I don't just have x this time, do I? Since I don't just have x, this one is going to be a chain rule. Since I don't just have x, it's going to be a chain rule. So I'm going to change this problem to be u is equal to 3x squared plus 1. My u prime would be 6x. And so now I'm going to rewrite this. So now if I rewrite this, it's going to be that's a u and that's a 4. So apologize for.
So you're just prime into
Now it goes in, and then it's going to be times u prime, right?
oh yeah.
Because whenever I do the chain rule, I haven't done it yet. That's why it still says ddu. Oh, you're right. Thank you. Sorry. Good job. So I haven't done this part right here. So that's why it doesn't have the u prime yet. So now let's do the derivative of this. So that's going to give me e to the u plus u 1/2 times u prime. Are we okay so far? Joseph? Not too bad, right? Okay. All right, so what do? I don't want all u's anymore. I want to.
Wait, don't you still have to multiply it by 1/2?
No, because when I do this, this is just u by itself, right? I'm undoing the integration with the derivative.
So
I don't have to do the 1/2 because it undoes when I do the 1/2 times that because I'm doing the integration at the same time. One step would be to take the derivative, right? And that would be the 1/2 comes out front, right?
Yeah.
Okay, integration would cancel me doing that step because it undoes my derivative.
I thought the derivative was the antiderivative.
Yeah, same thing. Integration is the antiderivative.
So then, how can you cancel it out if you're not doing all the steps?
I am doing the steps. That's so in this case right here, this is all this. Right here. If I only had a u, or in the case of previously, if I only had an x, it just substitutes in, right? And it undoes everything else.
Okay, so find the derivative of what you're substituting. You're not like the. Yeah?
That was because it's right there in the corner. More complicated than just x by itself.
So you still do only find the derivative of whatever your.
I substitute that because it was not just x by itself.
Yeah.
That's why. It became a chain rule. So, right here, I'm going to be left with my u value was 3x squared plus 1 plus 3x squared plus 1. All that is to the 1/2 times my u prime. My u prime was 6x.
So that's where the other one cancels out because the u prime would have been 0. So that's going to be 0.
On the bottom where that 4 is.
Yeah.
All right, so before we get into I think I could stop here. Yeah, because I want you guys working on these problems before I do the next one here. So go try these problems. Work on the first. Homework set was.
Is this all for 8?
I think so. 5 through 35 odd. Yes. All right, there we go.